Hello, myself I'm KH1 from CSC Section B. My topic is what is NumPy? Python is a simple, dominant, and well organized interpreted language. Python is used to develop the very high performance scientific related application, and it is used to develop an application for numeric computation. It is frequently used. Using Python, we can develop a high performance applications. Python often utilizes external libraries to perform scientific computing. The most important libraries used are NumPy, SciPy, and Matplotlib to perform scientific and numeric applications. The Python libraries are open source tag on modules, which do additional frequent mathematical and numerical routines in precompiled high-speed tasks. These two modules are providing the functionality that meets or perhaps exceeds that related with common commercial software like MATLAB. The Python package NumPy numeric Python is used for manipulating large arrays and matrices of numeric data. Next point, the scientific Python SciPy extends the functionality of NumPy with a considerable collection of valuable algorithms like minimization, Fourier transformation, regression, and other applied mathematical techniques. Matrix Laboratory (MATLAB) is a multiple programming paradigm. It is used for numerical computing environment and it is a proprietary programming language. The following various operations are performed by the MATLAB. Operations are plotting of functions and data. Matrix manipulations Python use as interface for user to interact with an application. Some type of algorithms are used for implementation purpose and another type of programming languages are used to create interfacing with programs. The combination of the following three packages NumPy, SciPy, and Matplotlib or Pylab are alternatively used as a MATLAB. So these three packages give the alternative to MATLAB, and MATLAB environment is best suited for scientific works. Python provide a alternative to MATLAB. And what is NumPy? NumPy is the fundamental package for scientific computing in Python. It is a Python library that provides a multi-dimensional array object, various derived objects such as masked arrays and matrices, and an assortment of routines for fast operations and arrays, including mathematical, logical, shape manipulation, sorting, selecting, discrete, Fourier transforms, and basic linear algebra, basic statistical operations, random simulation, and much more. At the core of the NumPy package is the NumArray object and array object. This n-dimensional arrays of homogeneous data types with many operations being performed in compiled code for performance. There are several important differences between NumPy arrays and the standard Python sequences. NumPy arrays have a fixed size at creation, unlike Python lists, which can grow dynamically. Changing the size of an end array will create a new array and delete the original. The elements in a NumPy array are all required to be of the same data type and thus will be the same size in memory. The exception, one can have arrays of Python including NumPy objects, thereby allowing for arrays of different sized elements. NumPy arrays facilitate advanced mathematical and other types of operations on large number of data. Typically, such operations are executed more efficiently and with less code than is possible using Python's built-in sequences. And next, a growing plethora of scientific and mathematical Python based packages are using NumPy arrays, though these typically support Python sequence input. They convert such input to NumPy arrays prior to processing, and they often output NumPy arrays. In other words, in order to efficiently use much, perhaps even most of today's scientific or mathematical Python based software, just knowing how to use Python's built in sequence types in insufficient. One also needs to know how to use NumPy arrays. The point the points about sequence size and speed are particularly important in scientific computing. As a simple example, consider the case of multiplying each element in a 1D sequence with the corresponding element in another sequence of the same length. If the data are stored in Python lists A and B, we could iterate over each element. We can see here code. This produces the correct answer, but if A and B each contain millions of numbers, we will pay the price for the inefficiency of looping in Python. We could accomplish the same task much more quickly in C by writing. For clarity, we neglect variable declarations and initializations, memory allocation, etc. These saves all the overhead involved in interpreting the Python code and manipulating Python objects, but at the expense of the benefits gained from coding in Python. Furthermore, the coding work required increases with the dimensionality of our data. In the case of a 2D array, for example, the C code, abridged as before, expands to. And next point, NumPy gives us the best of both worlds. Element by element operations are the default mode when an endary is involved, but the element by element operation is speedily executed by pre-compiled C code. We can see here the code. NumPy targets the Python reference implementation of Python, which is a non-optimizing bytecode interpreter. Mathematical algorithms written for this version of Python often run much slower than compiled equivalents. NumPy addresses the slowness problem partly by providing multi-dimensional arrays and functions and operators that operate efficiently on arrays. Using these requires rewriting some code, mostly inner loops using NumPy. Using NumPy in Python gives functionality comparable to MATLAB since they are both interpreted and they both allow the user to write fast programs as long as most operations work on arrays or matrices instead of scalars. In comparison, MATLAB boasts a large number of additional toolboxes, notably Simulink, whereas NumPy is intrinsically integrated with Python, a more modern and complete programming language. Moreover, complementary Python packages are available. Skype is a library that adds more MATLAB like functionality, and Matplotlib is a plotting package that provides MATLAB like plotting functionality. Internally, both MATLAB and NumPy rely on BLAS and LabPack for efficient linear algebra computation. Python bindings of a widely used computer vision library OpenCV utilize NumPy arrays to store and operate on data. Since images with multiple channels are simply represented as three-dimensional arrays, indexing, slicing, or masking with other arrays are very efficient ways to access specific pixels of an image. Inserting or appending entries to an array is not as trivially possible as it with the Python's list, NumPys. operation does not actually link the two arrays but returns a new one filled with the entires from both given arrays in sequence. Reshaping the dimensionality of an array with the NP reshape, it is only it is only possible as long as the number of elements in the array does not change. These circumstances originate from the fact that NumPy's arrays must be views on contiguous memory buffers. A replacement package called Blaze attempts to overcome this limitation. Okay. As a result, several alternative array implementations have arisen in the scientific Python ecosystem over the recent years, such as Dask for distributed array and TensorFlow or JAX for computations on GPUs. Because of its popularity, these often implement a subset of NumPy's API or mimic it so that users can change their array implementation with minimal changes to their core required. A recently introduced library named CUPY accelerated by NVIDIA's CUDA framework has also shown potential for faster computing, being a drop-in replacement of NumPy. What is NumPy first? Vectorization describes the absence of any implicit looping, indexing, etc. in the code. These things are taking place, of course, just behind the scenes in optimized, precompiled C code. Vectorized code has many advantages, among which are vectorized code is more concise and easier to read. Fewer lines of code generally means fewer bugs. The code more closely resembles standard mathematical notation, making it easier typically to correctly code mathematical constructs. Vectorization result in more Pythonic code. Without vectorization, our would be littered with inefficient and difficult to read for loops. Broadcasting is the term used to describe the inflict element by element behavior of operation. Generally speaking, in NumPy, all operations, not just arithmetic operations but logical, bitwise, functional, etc., behave in the inflict element by element fashion. Example, the broadcast. Moreover, in the example above, A and B could be multidimensional arrays of the same shape or a scalar and an array, or even two arrays of with different shapes, provided that the similar array is expandable to the shape of the larger in such a way that the resulting broadcast is unambiguous. For detailed rules for broadcasting, see broadcasting. Advantages of NumPy. NumPy arrays take less space. NumPy arrays are smaller in size than Python list. A Python list could take up 20 MB size, while an array could take 4 MB. Okay. Arrays are also easy to access for reading and writing. The speed performance is also great. It performs faster computations than Python lists. As we can see, it is really strong in terms of high. Next point. Algorithms that are not expressible as the vectorized operation with typically run slowly because they must be implemented in pure Python. While vectorization may increase memory complexity of some operations from constant to linear because temporary arrays must be created that are as large as the inputs. Runtime compilation of numerical code has been implemented by several groups to avoid these problems. Open source solutions that interoperate with NumPy include Skype, Wave, NumXPR, and Numba. Python and Python are static compiling alternatives to these. Many modern large-scale scientific computing applications have requirements that exceed the capability of the NumPy arrays. For example, NumPy arrays are usually loaded into a computer's memory, which might have insufficient capacity for all the analysis of large datasets. Further, NumPy operations are executed on the single CPU. However, many linear algebra operations can be accelerated by executing them on clusters of CPUs or of specialized hardware such as GPUs and TPUs, which many deep learning applications rely on. As a result, several alternative array implementations have arisen in the scientific Python ecosystem over the recent years, such as Dask for distributed array and TensorFlow or JAX for computations on GPUs. Because of its popularity, these often implement a subset of NumPy's API or mimic it so that users can change their array implementation with minimal changes to their code required. A recently introduced library named CUPy, accelerated by NVIDIA's CUDA framework, has also shown potential for faster computing, being a drop in replacement of NumPy. Broadcasting is the term used to describe the inflict element by element behavior of operations. Generally speaking, in NumPy, all operations, not just arithmetic operations but logical, bitwise, functional, etc., behave in this inflict element by element fashion. Example, the broadcast. Moreover, in the example above, A and B could be multidimensional arrays of the same shape or a scalar and an array or even two arrays of with different shapes provided that the smaller array is expandable. So, to the shape of the larger in such a way that the resulting broadcast is unambiguous. For detailed rules of broadcasting, see broadcasting. Conclusion. As we can see, it is really strong in terms of high quality library functions it has. Anyone can perform large calculations or computations with just a few lines of code. This is what makes it a great tool for various numerical computations. If anyone wishes to become a data scientist, then they can try mastering, but first you need to learn and know Python before becoming an expert in NumPy. So, thank you.